standard deck of cards contains 52 cards divided evenly into 4 suits. So if the cards are divided evenly into 4 suits, 52 divided by 4 would mean that there are 13 cards of each suit. The suits are hearts, diamonds, which are red, and clubs and spades, which are black. So half the cards are red, half the cards are black. 1/4 of the cards are hearts, 1/4 of the cards are diamonds, 1/4 of the clubs are spades, 1/4 of the cards are clubs. Each suit is composed of cards numbered 2 through 10 and a jack, queen, king, and ace. So that's what the 13 cards are all numbered differently in each suit. So let's take a look at what is the probability of selecting a heart or ace from a standard deck of cards. The key word here is or. We've got one of two things happening, so either one makes the statement true. Heart or ace is okay. Well, we have to start with this or, talking about whether or not it's possible for both to happen. Because sometimes, and in this situation they both can happen, there's a way that the card could be a heart and an ace at the same time. So we're going to have to use our inclusive probability model, which tells us that when we have the word or, the probability of the first outcome plus the probability of the second outcome minus the product of those two probabilities will give us our probability. So the probability of a heart, we have 13 cards that are hearts out of 52 total cards. So our probability of a heart is 13 out of 52. The probability of an ace, there are only 4 aces in a deck, one of each suit, and those are out of 52 cards. So guess what? We've got the ace of hearts counted here and here. You're not allowed to count it twice. So we have to subtract away that ace of hearts. And the way we're going to figure out the probability that we get an ace of hearts, we could kind of shortcut this and say it's 1 out of 52, but this formula will work in other situations, so it's important to know this formula. We're going to go ahead and do 13 out of 52 times 4 out of 52. And what we're going to discover is that this product will actually give us the 1 out of 52. Let's go ahead and reduce these two fractions. 13 out of 52 is really the same as 1 out of 4. 4 out of 52 is the same as 1 out of 13. So we have 1 out of 4 times 1 out of 13. 4 times 13 is 52, and 1 times 1 is 1. So we've got, and keep in mind, all we've done is simplify that product. We never did add these other two, and I'm just going to leave them as they are as I go down through that process. So now we've got 13 50-seconds plus 4 50-seconds. 13 plus 4 is 17 50-seconds. Minus 1, 17 minus 1 is 16 50-seconds. And when we reduce this, 16 divided by 4 is 4, 52 divided by 4 is 13. We get 4 out of 13 is our probability of drawing a heart or ace out of a deck of cards. Okay. Let's take a look at number 5. Here we have that word or again. It's the probability of selecting a king or queen. Again, the first thing we have to ask ourselves, could both things happen at once? If I drew one card, could it be both a king and a queen? And in this situation, no, it cannot. So this one will be a mutually exclusive model. And here we only have to add the sum of the probability. The probability of a king plus the probability of a queen. And the probability of a king would be 4 out of 52. The probability of a queen would be 4 out of 52. Equals 8 out of 52. And 8 divided by 4, we're reducing this fraction. 8 divided by 4 is 2. 52 divided by 4 is 13. The probability of selecting a king or queen is 2 out of 13.